Hello guys, this is episode 4 of System Design 100 and you are watching Load Balancers. So in my last video when we were talking about database application, you might have heard about these terms, right? Performance, reliability and high availability. And I was talking how database application can be proven very helpful to manage these properties because having multiple copies of a single database so that we don't have to route all of the requests into a single database instance, and we can save it from being overwhelmed and going down. Reliability is that even if one database instance goes down, we have the other one which can take care of the request for some time until the other one comes up again. So we have reliable application. Similarly, reliability and high availability, both of them covers the same point that I just explained. Now, you might be thinking like we have saved the database from any kind of issues by considering these points, and now we have a very good design of database that can handle a lot of issues. But you can see here we still have a single web server here, right? Now the earlier issue that I was pointing about as a single point of failure, this point can also as a single point of failure. For example, doesn't matter how much replication of databases we have, if the web server, which is also a server in the end, right, just like in the database service, goes down, then our application will collapse. Doesn't matter how many database instances we have. If there is nothing to serve the users as a front end, the application will stop working, right? Our functionality will go down. So to consider this thing, we can introduce in a similar way, just like instance, we can introduce another web server here in our design. So instead of one, we have two web servers. So depending on how many web servers you want to introduce, these all will have same instance of the web application that we have, so that users can either go to this server and this server and this server. So even if one of the servers goes down, we have other servers doing its work, so that our application doesn't go down. Similarly, our performance can be improved if we have a lot of users. The user don't have to all of the requests don't have to go to a single web server. It can be divided into multiple web server. And reliability, high availability, I just explained, right? We don't have to worry about a single database, single web server going down. But the question here is how this can happen, right? Because I just told you, right, all of the single web server, they have their own address, and the user can resolve this address using a DNS and then contact the server. But introducing multiple web servers, how a user will do it, how a user will decide, right, which server to go. And since there are multiple addresses, how the request will be routed, right? And how would I know that this server has two requests, so this server also should have two requests, right? There is no way of knowing that how many requests are going to which server. One server can be overwhelmed because we do not have any information about that, right? Now in this case, there is a web component which is called a load balancer is used. Now, load balancer is part of the web server architecture only. So it is placed between user and web server somewhere around here, and similarly something like this, and it distributes the incoming traffic into the whatever number of web servers we have. So for example, one is this and two is this. Even if we have more, it can route traffic to that. So we have multiple algorithms or multiple ways, like round robin and weighted routing kind of stuff to route the traffic among the servers. But still, that, right, we still have two servers, right? We have address of two servers. For example, this server also has the address of 192.168.1.2, and this will also lead to google.com. But how will we know that how which server to route to? How will we know that? Now, in this case, what we do is that instead of providing a public IP address to our web server, we provide a public IP address to a load balancer. So instead of this web server having address of this, our load balancer will have address of this 192.168.1.1. Okay, and once the request reaches this load balancer, the balancer internally decides which web server it has to route the request to. Now, what we do in this case, there is something called a virtual network inside of this. So we have given a public IP address to the load balancer, but internally, when it is routing traffic, it uses the private IP addresses. So private IP address is the IP address which is contained inside the virtual network, which defines the address of a web server inside the virtual network. It's a little advanced topic, but yeah, do not worry about it. So it is a private address which is not accessible to the public, but only to the load balancer, because it's an internal application. It's an internal component to the web cloud provider or whatever service you are using. So even though you are contacting this load balancer, internally load balancer knows how to distribute traffic among the servers. If this server has a load of 60%, and if this server has a load of 20%, load balancer internally have algorithms that it can work on to decide. No, we now have to route traffic to this web server, right? So yeah, this is load balancer. Thank you very much.